Welcome back to Goliath. Today we're going to be talking about reference designs. This is another reference design that Goliath has developed, or Mike has developed, about power monitoring. And this is an exciting one because we see this a lot in terms of what people are trying to do with IoT devices and development. Mike, can you tell us a little bit about why someone might be trying to do power monitoring and connecting to the cloud?
Yeah, so a big motivation for us is thinking about industry. So let's say you have a big machine shop, you have a lot of tools in that machine shop. You want to monitor what the runtime of those tools are and how they're running to see if they are, maybe getting closer to needing service or, running as expected. But there are a lot of side benefits to having that kind of those kind of analytics. Like for instance, you can find out that your shop is like one machine that is getting used like almost all the time, and maybe it's a
That's right.
bottleneck for your workers. And so if you're able to add another machine, you might be more efficient and be able to get jobs done quicker.
Yeah, capacity and analysis, being able to capture that data, give it to your big data team, and then they can do analytics on it. It's really really useful from a saving money or increasing output. So that's a great example of one there. Uh,
Yeah, and there's a
so
growing
you
consumer side to this as well. So like people like the same kind of information in their homes to see like what things are running, like how can I reduce my power footprint, like just to have a little bit more information about what's going on with the systems that are around them.
Yeah, and that's a great lead into how you're going to be showcasing some of this stuff today. Before we do that, can we talk a little bit about the hardware and then what you had to do to actually get this all connected to Goliath and then to a visualization platform?
Yeah, absolutely. So I have a picture of the actual hardware here. On the right panel, this is the device itself, which we're calling the Aludel Mini. It's one of our standard reference design starting places. Underneath this green board, it has a SparkFun Thing Plus NRF 9160, which is a cellular modem. And it's connected up to these two boards, which are ADCs. They're MCP 3201s that are reading current clamps. So this blue thing right here is a current clamp that you would put around a power line, and it would be able to read back through the ADC to the cell modem and up to the cloud what kind of current is being used on each of your lines. On the left side, you can see the the breaker box from my basement. I've actually hooked it up to two circuits. So I have one of these clamps over here on the right is going to the refrigerator and toaster oven in my kitchen, which is kind of fun to watch. We'll look at it in a minute. And the other one is going to my washer and dryer.
Awesome. Yeah, and this is, if you are going to do something similar here, please be very careful, like Mike was with his breaker box. This is with the cover off, but you would obviously close that up if you're using this longer term. Generally, I think it's also important to note that you could do this on a wide variety of other devices, but you do need to. One thing that always surprised me about it's like, oh yeah, you only can do it in power going one direction, right? So this is basically the right hand rule of physics. You have AC current going through the magnetic field around it. You could see power going through, but you can, if you do it on both the hot and the neutral wire, it'll cancel out because current's going both directions then.
Yeah, so actually for testing, I had a very carefully sliced extension cord that separated the two conductors from each other so I could get,
Yeah,
they were still insulated, but so I could get
of
the
course.
clamp around one of them.
Yeah, and so basically, you were saying that this is all translating from AC power, basically on your either your breaker box, the power cord that you're talking about. It's becoming a signal that's measured by the ADC and then captured by the NRF 9160, and it's running Zephyr and using all of the stuff that we built around the Zephyr SDK to then talk back to the cloud. What about that piece?
Right.
What's actually being used in the Zephyr firmware?
Yeah, so I think the biggest thing that's being used is our streaming data. So each time I take a reading, I upload that reading to our LightDB stream, which is time series data, and the Goliath will automatically timestamp it. So, each of these readings came in. I could probably put them on real time. I think I'm on like 5-second readings right now. So we should see these come in like every 5 seconds. It's also possible to cache these readings with your own timestamps and send them in all at once if you're worried about the connectivity being a problem. But you can see I'm just sending like raw ADC values because if you do calculations on the device, it can change based on the machine. And I think it's better to get like what's the raw reading and do the calculations in the cloud. Other things that I have going on here, I have a set of on time. So you can see the live running time is reported in milliseconds. And then a cumulative running time is stored here as well. I also have an option to reset the cumulative runtime because you can't just clear it out here. The device needs to know to clear it out as well. So that is set up that way. I have a few settings, which these can be fleet-wide settings, but I just have one device on this fleet. So fleet-wide settings are set at the project level. You can see I have ADC floors, which I'll talk about in a little while. But the one that I reset this morning so we'd have a little cooler data is the loop delay, which is how often the readings are being taken. So I had it like every 60 seconds, but it wasn't quite as interesting. And when we look at the graphing, I'll talk about that.
Fidelity, yeah, of course.
Yeah, absolutely.
Yeah, that's great. And I think another thing that we should point out here is that this is a cellular modem. This is sending from Mike's breaker box, garage, basement, somewhere in
it's
your
in the
house.
Basement. Yep.
Yeah, so it's so truly wireless, sending up to the Golioth cloud through the cellular network, and then we're able to see all this stuff here. And then from the Golioth REST API, then that's getting pulled out to this visualization platform as well. So much like you might have a shop floor with a bunch of different devices all over the shop floor talking cellular. We can also talk Wi-Fi, thread, a lot of different options there. Golioth really allows for hardware interoperability and being able to switch between different communication mechanisms and different chipsets. Once it gets to the Golioth cloud, though, it's all that data is in the same place, and then you can start doing interesting things like this visualization.
Yeah, so basically any visualization platform that you like to use is going to be able to hook into Golioth really easily. I'm using Grafana because it's something that we work with frequently, and it's just hitting our REST API and pulling the data for whatever window you're looking for. So I think I have a window of like the last 3 hours here, and it's kind of cool to start digging into what we're seeing on this. So if you do a little zooming in, this is the circuit that is for my refrigerator and toaster oven. And you can see when it kicks on, there's a little like inrush current to get it going. And then it runs pretty efficiently, like under 500 milliamps to run that compressor. And it runs for, a few minutes at a time, and then it shuts off. These in between are probably the door was opened, and then it ran to see if it needed to cool back down again. But one of the like aha moments is like right after I hooked it up. Let's see if I can find one of these here. Right after I hooked it up, something happened, and I was like, oh, what is that? And so I decided to go and take a look, and it is actually the toaster oven that my wife was making, like a breakfast bagel for my son. And you can see the toaster oven come on and go off and come on and go off because it's got a quartz heating element in it. And so I don't think that you can run like a variable voltage through those. I think it's all on or all off.
That's
in
right.
order to heat those. Other things that I thought was kind of interesting is you can see over here, this is my washer and dryer, and I'm not running my washer and dryer right now, but it's not at zero. So you can measure your like vampiric current, like things that are actually using current but aren't on in their standby modes. This one might be a little elevated because I actually have a nightlight, like an LED nightlight on that outlet, so that room's got a little bit of light in it since it's in the deep dark basement. But I was having a problem because the live runtime was set to look for 0 here, and so it wasn't looking for 0. So in Golioth actually added that ADC noise floor or ADC floor. So it's saying if your raw ADC reading is at 6 or below, then consider it off, and if it's above that, then consider it on. And that's how I can remotely alter, how I'm taking those readings.
Right. And if people haven't seen the Golioth settings before, basically this is on the cloud. You're looking at you're able to create kind of arbitrary numeric or string-based variables that you then can push down to each of the devices in your fleet. So in this case, ADC floor, channel 0, channel 1. And then in your Zephyr code, you then are writing code to react to that, basically. And so in this case, it's basically saying if it's below the floor, ignore it in Mike's calculations for this sort of thing.
Yeah, and you can see, like, we can look at the remote logs. This is live logs coming in for the device, and I can go to the settings and say, you know what? I want you to take readings every 10 seconds instead of every 5. And when we go to the logs, we should see a message come up to that. We may have missed it. Let me just turn this off and do a refresh. So
There it is.
received loop delay settings right here. So it was reset, and then it set the loop delay to 10 seconds. So that came in so fast that when I switched tabs, I actually missed the message.
Yeah.
So it is really snappy. Even though it's in my basement, it is going out to the Golioth cloud and coming back to the cell tower and hitting the thing in my basement through cellular.
Yeah, that's really cool. Yeah, it's just like, and it becomes this thing where you just have control of your device. Say you wanted to go then and implement a new setting. So say you have ADC floor, but now you wanted to set a ceiling. You go and create that new variable in Golioth settings. You update your firmware on your local device that you're developing on, and then you're able to go and push that OTA to all the devices in your fleet. And now they're all listening for this new setting and able to take action on it. It's one of those things where like your repetitions and your cycle time to develop a new feature really, really starts to explode, and you can deploy it to all of the devices you want to in your fleet.
I also put on here like the max reading. So it's really just looking for what the maximum reading in the window that you're viewing right now is. But with these platforms, you usually have an alarming option. So you could set a threshold here and have it, turn red to let you know when you're looking at this, like, hey, that's out of spec. You might have a bearing going out on your machine. Or the other one is like the live runtime is, did someone leave the machine running or the machine in idle? Is it something that's going to wear it out? And if that live runtime got to a certain point, you could then have someone go take a look at it. So I think just the availability of knowing what's going on is the most powerful thing here.
Definitely. Yeah, and I like how you talked about the raw data versus kind of the calculated data on the device side. So Golioth helps to make it so that you can push some of that intelligence down to your devices, but still a lot of the processing and a lot of the things that you might want to be doing in your visualization or in your calculations might be cloud side. You can really make that decision. Whereas I feel like some platforms also, or maybe even better to say, if you're doing a kind of DIY, you don't have as much control to push stuff down to your device. And I feel like a lot of that capability really starts to act faster and to work a little bit better when you are able to push that down to your device.
Yeah. And I think some of the interesting things, if you think about, am I going to put this on one machine or am I going to put it on a breaker? Well, in the case of my toaster oven and my refrigerator, like it's really easy to see which device is running here. You're looking at like I guess this one is just the on current, but if I go back to maybe like the last 12 hours, we're going to see that the top currents for that toaster oven are above 5 amps. So even if the refrigerator and the toaster oven are running at the same time, like your business logic will be able to very easily tell what's going on. So you could have a circuit with several different small machine tools on it and be able to tell like which one of those machine tools is running, unless they're the exact same model.
That's right. Yeah, and you can start to do machine learning, all that other stuff that's kind of floating in the air, all of the data sciencey type stuff that's out there, probably behind my
and that is like a business in a box thing too, though. Like there are companies out there that are taking like one current clamp that's connected up to cellular, and then they do machine learning to like figure out what's normal, what's not normal. So like you're already very close to that like fully integrated solution.
Yep, awesome. Were there any other elements of the Golioth cloud that you're using that were not shown here? RPCs or similar?
Well, obviously over-the-air update. So Golioth has over-the-air update by default. I have actually already used it with this device because I didn't have the ADC floor and I didn't want to get up and walk down into my basement with the laptop and plug something into the device. Now, it wouldn't take me long to do that, but this computer that I do a lot of development on is not my laptop. It's a desktop computer.
Long extension cord.
Right. Well, and if you think about pushing stuff up to GitHub and pulling it back down to the laptop and then going down, like that's not fun. Now imagine if the device that you're monitoring is in a different state or a different country or even just 3 blocks away. Like it saves a ton of time to have that over-the-air update available, and it happens pretty much automatically.
Awesome. Let's go take a look at a couple of videos of other examples and showing this kind of live in action, and then we'll be back to finish things up.
All right, we caught this at a really good time because you can see my refrigerator just kicked on about 1 minute and 30 seconds ago. And in honor of Golioth's upcoming appearance at a Better World in Germany, I'm going to be baking a frozen pretzel for you. So if we put this in the toaster oven and kick it on, we should see it come up almost immediately. There's the quartz element turning on, and we see that the graph is going to immediately refactor because it was topping out at 1.5 amps. Now it is topping out at 5 amps, and we should see the element switch off, and we'll see the data go back down. We're looking at about the last 2 minutes of time here. There it is going off, and you can see the latency is really quite good on here. We see it coming down right away, so you can get a lot of pretty good real-time data from this, and of course you can go back and analyze it later. All right, everyone. I've been greatly enjoying my hot pretzel that I just made, and unfortunately, I got some of the salt from it onto the carpet in my office here, so I'm gonna need to clean it up. And in the right channel, channel 1 here, I've switched that over to an outlet, and you're going to see the vacuum cleaner on the power monitor. My office rug is clean again, and I can go back to enjoying my pretzel. So I'm really glad that you stuck around to take a look at the power monitor. If you want to learn more about the parts that are on the power monitor or a little bit of what's going on around it, you can check out projects.golioth.io and see kind of an outline page for each of our different reference designs there. Of course, there is also a blog post that covers this reference design itself a little bit more in depth. And Chris, I think we'd always like to talk to people if they want to set up.
I would love to talk to people. Yeah. If they want to talk to us, they could find us. They can always reach us on forum.goliath.io. You can also email devrel@goliath.io. And there's a hello@goliath.io for more general questions about the platform as well. Mike, thanks for sharing this. I can't wait to see what else pops up out of your power monitor in your house. I think this is really, it's interesting and exciting to see this sort of stuff, just live on screen. It's really cool.
Well, thanks, man. I had a lot of fun doing it, and I bet it won't be long before we're back with another one.
That's right.
All right. See you then.